Hey guys, how's it going? Welcome to another episode of Ferris Makes Emulators. Episode 42, Bug Squashing Part 18. Still working on this Mario Tennis bug, but in the last episode, I actually totally forgot to open up this file. But I think we're basically done capturing data in order to fix this bug. We may not be. Don't want to jinx it. We got some really good data. This is kind of the culmination of our hard work the last few weeks. It basically is the three of the different display state registers. And what this basically tells us is that the way that we're transitioning states in Rush to a Boy is just not right. Like when we're doing that throughout the period of a frame. And thinking about it, I'm actually kind of suspecting this may not have been accurate enough, because one of the things that we're not really measuring is what the timing difference is between when a frame starts and the start of frame processing interrupts happen, or rather when the I think it's, which one is it? I thought one of these had a start of game frame and also a start of frame processing. Anyway, we'll see if that causes any problems. But for now, we'll go with this, because I know that there are already definitely things that we can do that are concrete. So this could be cool. By the way, hi to guys in the chat. Dana Collins, Skeleton, Chief Detector, Daru2, Dom170, Pyro ESP. Yeah, Dom170, that stuff's wicked expensive. It gets really expensive really fast. Hey, Alkama. Alright. That was Mario Clash, by the way. Pretty cool game. Anyway. So basically, we're working on this test ROM, and what's it testing now? The interrupt pending register. So just running this in something like Midnafin, for example, just to make this build. This is what it looks like in Midnafin. On the hardware, we see this thing here. And if we run this in Rush to a Boy, for example, we see something like this. Missed you too, Alkama. Cool, Chief Detector. Can be super satisfying just to write tests. But yeah, so this is our interrupt pending register, and already you can see that there's some difference in the timing here. Things are not, for some reason this happens twice, which is somewhat interesting, or that's perhaps this one actually. A couple other things. I think I wanted to pick one of these registers and focus on it first, like the display status one. I think will be sort of an easier one to start with. And I think kind of just massaging things in order to try and get them to work is kind of the right strategy here. Currently, I'm doing the time based on quarter frame intervals, which is not really enough to describe all the nuances here. And particularly, we need at least 8th frame intervals in order to replicate these frame buffer being displayed bits of the display status register accurately. Let me go ahead and pull that up, actually. Pull up the branch of that code that's doing that. Yeah, let's go ahead and build this. So this is our display status. And like if we compare these two here, A couple things to note. First of all, these do take about a quarter of a frame. It's just that they're offset on the actual hardware. And they actually move around quite a bit, and I'm guessing that's just because like does the left half for the the left stuff, and then the right half here for when it's displaying the right stuff. And then they're flickering because there's actually 2 frame buffers per eye, and every other frame it'll display out of a different one. And that's how the double buffering works in the hardware. But yeah, I'm guessing they reserved the entire like half frame here and half frame here for each eye. And then as the display will stabilize, it'll kind of center itself within those regions. But I think in terms of getting this correct enough in our emulator, I think we only really need to assume that this is going to be stable just to get sort of these intervals more or less correct. Interestingly enough, most of everything else matches. However, 1, 2, the second one is display sync enabled. That's correct. VIP memory is refreshing. It seems to be always on, and in our case, it's like never on. So that would be an easy one to fix. I don't recall that flickering or anything on the hardware. This one, display procedure is beginning, seems to be held for half the frame, which is kind of interesting. A lot more than I would have expected, but basically just adjusting that I think will be okay too. And then displays ready is always set. So we have these ones, and displays enables basically always set. So I think we'll be okay here. Hey, Dark Second. This one, I think I know how high this counts up actually, because I think I already have a timer. I looked at the code a little bit earlier. I think I have a timer already that's counting that interval. I think it's this one here, this SB out period, if I recall correctly, which is every 56 microseconds, is how fast that was climbing up. So I think that'll be okay. And this writing stuff ends up happening pretty early on. I'm wondering if I can sort of adjust these to be halfway in this period, and maybe that's correct enough. We'll have to play with it a bit, but then I can just get away with doing 8th frame intervals, and that would be really convenient. So I think I might try that, and then this should more or less match. Hey Ripnop, thanks for stopping by. Hey Love Like Semtex. So yeah, I think if we try to do this as 8th frame intervals, I think we'll be okay. We'll have to see. But yeah, so I'm basically, my plan here is just to really only use this test ROM as a test case for this. Here's Aquar. And I think if we just sort of adjust this so that all the different visualizations for the different bits match enough, then I think we should be good to start trying games. And hopefully that will basically fix stuff. But we'll see. We'll have to see. So yeah. First thing I'm going to do is this quarter frame period thing. I'm just literally going to rename it to 8th period. I think that's how you spell 8th. And it's going to be over 2.5 milliseconds. It's going to be half this many clocks. I like to have these comments here to show how this was derived. That's nice. And then, so if I just do that, then this is going to start looking a little weird. Takes a minute to build. Okay, actually looked okay. Bit surprised about that. But yeah, let's go with this. Oh yeah, also this stuff is going to be wrong. It probably actually just made everything periodic because it's still probably doing 4 periods, but that just probably just made them half as long. It's probably actually what that did, just changing that. But that's fine. We'll go ahead and start working on this. I'll leave this drawing period stuff here because we're not going to worry about that for a while. Just want to try focusing on Yeah, on this display status thing. Sorry, Tribo. I have links blocked. So, guys might have to whisper. Sorry about that. Yeah. Word. So it's down here, basically. We have I have a quarter clock counter here, which I also am going to want to rename here. And this will count up clock values until we hit a certain threshold, and then it will increment this quarter counter here, which is basically the index of which quarter we're in. Of course, that's going to become eighth. We can basically start searching where that's used. So yeah, so we count the eighth clock counter until it hits the eighth period. Once we get that, then we will... okay, so this actually resets it to 0 even. Oh no, that resets the clock counter. There we go. And then here's our 0, 1, 2, and then 3 quarters initially. But we're going to change this a bit. So particularly, these basically fire at the same point. I think I recall on hardware these just flickering with the display finished. We're going to have to keep in mind some of this stuff is still happening here, but we just focus on a couple of the signals. Maybe that'll be easier. So first of all, this display procedure beginning thing is particularly interesting. How do I do that currently? I think the display procedure beginning is here. I think I actually create that state. That's display control read. Which I think is actually the one we want here. I just have it named a little bit differently here. I would actually like to go through some of the documentation laying around and sort of clean up a lot of these names at some point, but we're not going to do that today. But I think it was, which bit was that? Need to get the documentation here as well. So this was display procedure beginning, which is bit 7. This frame clock, I call this. That is the one though, and so it's basically when the display state is in idle, I have that true, and then otherwise I don't, and that's gonna be wrong. So let's do this. Now that we actually know what this is gonna be, it seems to be half the frame. It seems to end up enabled over here, and then just takes up half the frame. So we'll just do that. That shouldn't be too hard. Is that used anywhere else? I use that to call this function here. Yeah, that's crap then. This name here. Might have used that for something else previously, but that's not what we need here. And here we can just do if the counter, the state counter here. In fact, I'll even do this. Self dot, it's eighth counter is less than 4. I think we get that already. So that should do it for that bit. However, I need to move some things around here in order to make this a little more appropriate. Because I think this will... Okay, yeah, so this is the looping logic. So let's put this at 7. And most things might start falling into place if we just do that. I mean, these are all going to be wrong, these indices here, but that should be fine. Yeah, so now we're getting something like this, which totally makes sense for the logic we have here. So I'm actually pretty okay with that. Interestingly enough, this transitions, I would say, earlier than I would have expected. Wonder what that's about. Anyway. Oh, it might be due to that reset logic, actually. So here it counts up to this. Weird. Let's start sort of massaging things here. So after 1/8 period, then we're gonna start displaying the left stuff, and then 2/8 later we're gonna stop displaying the left stuff. So this is gonna get a little jank here, but I think we just do something like this, or no, because we actually have to split this one up. So this is gonna do, let's display finished on 3, and that's still somewhat correct, I think. Also, this display thing, by the way, is going to actually output the frame buffers to the rest of the emulator, so that's something else. So yes, basically 0, 1, 2, 3, 4. Yeah, 0, 1, 2, 3, 4, 5, and 6. It's going to do this stuff. I'm going to keep these nested for a sec. And then on 7, we're going to do some stuff. I'll do that here. Now we have a lot of cycles where we don't do some stuff. So we'll just do something like this. Keep that empty for now. Interesting. So I actually think I know what's going on here. I'm fairly certain that this begin write display process, there's some things here with how I change the display state. And I think I'm going to put it into idle here, actually. It's starting to make less sense to use the states how I'm using them here, and actually I might just start modeling these as the individual bits. Though I think, I think I'm not getting much out of those at this point. So let's see. Yeah, for now, just setting this to idle will work. So I think what I want to do here, kind of break this up like this. And this will do something like something like that. Right. Yeah, something like that. And I think, yeah, then we'll have the right stuff here. Start with that. Yep, so we're already getting a little closer here. And I just kind of want to keep massaging it until we get this stuff right, because it'll be less annoying than just doing it from scratch. Although the fact that this is offset is a little concerning to me. I don't know why that is. Because the way I see it, we'll do... Whoops, wrong one. 0, 1, 2, 3, 4, 5, 6, 7 will be our different states there. And that particular bit was here. Bit odd. Especially that these are in sync, actually, is a bit strange. Oh, we'll actually change this to be more symmetric with the one above. Been a while since I dug into this code. Yeah, so we have the frame clock on the 0th one. Maybe I should do the transition before I do this. I think that would make sense, actually. I'm kind of switching these based on, yeah, based on which one we're in, but then we switch it right after. So I think this would actually make more sense here. That would probably explain a lot of that. Oh, it's a beauty. It's more or less exactly what it should look like, except for one of the bits that we had up here, which we can just fix at the same time. So in this case, that was the memory refreshing. And I don't really know what the context is for it doing that. From what we see in this test, it's basically always on. I'm actually going to make it the same as the display. No, because you can still write to this basically when the system's starting up. And if you can access the video memory, it's likely being refreshed. So we're going to do this and just have this to do here. Because I still am not 100% sure that's correct, but it'll match what we're seeing, and it should make sense, because that's what you have to do with DRAM, is you have to refresh it if it's going to store any data. So that would make sense that it would at least appear to be constant. And with that, this basically matches the top one. Even transitions here nicely, which is kind of interesting. Wouldn't have expected to catch that at the end there. Okay, so this might be progress. Let's switch registers and see what we're getting. Particularly, let's do the drawing status. Now, what I expect to happen here is that we're going to have to sort of go back and forth a bit. Sort of fix these things and then check the other stuff and make sure that they match. So I expect this to go back and forth a bit, but maybe that was easier than I thought. That's looking pretty good, and I guess it's because we have that 56 microsecond interval correct, because that would basically make this match. Except for this thing that we noticed last time, where the current Y position just seems to stay there, which is kind of funny. I think we'll make that match. There's also the drawing Y position sits there in strobes, and I know that that's probably not going to match here because we had that masked out in the hardware test, and I'm pretty sure when we had that in, it was actually incorrect in this emulator. I want to ignore that for this because I don't think that that'll be what's going to cause problems. And I'm guessing as well that we basically need more testing to get that right, I think. But that was... Okay, first of all, it's this SB count that's going to count out this value, and then the SB out, I think, is whether or not it's accurate. And I think, what am I doing here? Where am I actually changing this? Yeah, while it's in the drawing state, then I just do all this. That makes sense. This will be the counter for that. But it's here with this SB count thing. What's the logic here? Okay, so if it gets to the end, I reset it to 0, and that's clearly wrong. Where else is this touched? Is this touched here at the begin drawing process? Okay, then I think all we have to do is remove this here. I think that's all we got to do there. Got a fun new warning since I upgraded Rust. All right, that's great. They linger a little bit here, and they don't here, and that may not be particularly relevant. But from what we can see here, this is good. But the drawing at Y position thing, I would like to add a note on that in the emulator code, which I think is the SB out thing here. So that's kind of the goal for today. We try to match the hardware, and where we either can't or where I don't think we need to, we're going to make notes of it because we want to get as much out of these captures as we can. But I think that's basically it for those two. Before I move on, I'm going to just run this one more time. I think all I changed was that comment, but it should be fine. And then additionally, I want to check out the other register that we just checked, just to make sure that that's still correct. Looking good. And this is still looking very good. Okay. So we'll do the last one, which is the interrupt pending one. All I'm doing, by the way, here is just switching branches on the hardware test repo, which is why I set it up that way. Then we'll build it, and then we'll run it. All right, so I think already we're actually going to match more than we did before, because a lot of these transitions here are based on other states changing at the right times. So like in particular, this drawing finished one is going to happen at the right time now that we have the state transition more or less in the right place. Especially these display finished ones are going to happen in the right place. The drawing at Y position match is the only one that doesn't really match here, which is actually a really good sign, because that's the one that strobed and there was some weird behavior with that. I'm actually going to leave this as it is, and we're just going to run some of these games and just to see if this even helped. So, yeah, it'd be amazing if this was all we had to change, but I don't know, but we need to just start running some stuff, I think. Let's start with Mario Tennis. Just because. Yeah, this is exciting. I don't know if you guys can tell, but I'm just I was kind of tired starting the stream, but I'm actually starting to get like nervous excited. Damn it. That's disappointing. Okay, well, we didn't break this. Let's try some other things here because that was really annoying. Let's try, what do we want to do here? I want to just run through a lot of these to see if they still work. Looking good. So even if we didn't fix that Mario Tennis bug, we may have actually fixed other bugs. Drew2, I didn't end up changing anything for the interrupt pending register. So if the last change you actually caught was the drawing status, then you actually are caught up. Other than that, I don't think I changed much either. It was really the state transition timing that we checked. This all seems to work great. What I'm gonna do though is I'm gonna pull up Rustral Boy, the repo, because we have this compatibility list, and I actually want to test these games in particular. Galactic Pinball. It'd be really interesting if, I doubt that will have changed, but I want to go through that list in particular just to see if there's any difference. If not, I kind of know where to. I think I know where to dig in a little bit more precisely with this stuff. And either way, I think we made some improvement here. So, man, it's been a while since I heard these sounds. Forgot how much I love this music. That still plays a little too slowly. We expect that. I actually really want to try golf. That was the one that we kept trying to glitch. And it also transitioned to demo mode like really fast. And I have a suspicion we may have fixed that by fixing these timings.
P and Esau present.
No, I don't think we did. That looked about the same. Which is interesting. All right, let's just kind of go down the list here. So I know that Space Squash was particularly problematic, because that one wouldn't start before, but here it starts. So we didn't break it further. Space Invaders had some issues with the lasers not showing up. Let's see if that's still a problem. This intro sequence, by the way, used to have a lot of bugs. And they were actually fixed by moving around these states initially, which is kind of interesting. Which is also why I want to test these, because after we move them around, this stuff should basically work still. Those upside down letters, by the way, those are totally correct. No, still got the invisible lasers. That's annoying. Nestor had some stuff. This is so disappointing, you guys. This one had some nasty intermittent failures before. Like there, the screen just goes black. That's so weird. So that wasn't fixed. I'll try virtual bowling. Still getting small timing glitches here. Although the graphical glitches were gone. I'll run that again. Because if we fix that, then that's actually a good sign. Like if that's the only thing that changes, at least we made some progress. But I actually think I might know where to look next. Yeah, I'm gonna do git stash on that and run this again. and I'll explain why. And then I want to run a couple of these other ROMs just to see if this is correct. So when the ball hits the pins and it like explodes, there'll be a graphical glitch for like a frame. Yeah, I don't know. It was really hard to see, but it totally happened. Right when the ball hits the pins for like a frame. There's a graphical glitch. And if we pop, we seem to have at least fixed that. And it would make sense that that might be timing related. Which is why I was kind of hoping that that would fix some of the other issues, but ugh. Yeah, no graphical glitch there. Yeah, that would have been a little too easy. I mean, at the same time, it wouldn't have been because it was easy because we grabbed all that data. And this exact combination of things I probably wouldn't have run into had I done this without getting that data. I think this game's funny. Any other games that used to have issues? Not really, but I'll run a couple anyway, just to make sure that things are looking good. I haven't run some of these games in like 6 months. It's almost nostalgic. Yeah, there's 2 bowling games, which is so weird. I guess it's like a fairly safe game mechanic and sort of gives you that perspective. But man, there are not enough games on the system that actually really play to the whole 3D thing. Speaking of which, Tellero Boxer had those audio glitches. And I would love for those to be fixed. Like, I just want to merge some code that actually makes some progress. Gonna let this play out just to observe. Yeah, dog does look like Jake. That's funny. All right, moment of truth. Ah, still did the glitch. Ah, boy. Okay. All right. Well, it fixed. That's so annoying, you guys. So we definitely improved this. I don't think this was all for nothing, though. And the reason is, first of all, we did fix one thing, which was the graphical glitches in this. So I'm actually going to commit this really quick, just to this branch at least, which is the real frame interrupt. And I think that's a fine branch to do this on. Yeah, nothing else appears to have broken. I didn't test that extensively, but I'm feeling pretty good about this, to be honest, because like a lot would have to break here. Or like, there's enough surface here between these games that something should have broken. By the way, these graphical glitches where like a frame sort of lingers when it switches, that totally happens on hardware. Some of those bugs, just have to keep reminding myself, are totally not bugs. Oops, I wanted to do the demo mode here, actually. The demo mode's really cool in this game. Yeah, so where to look next? One of the things I'm actually a little suspicious of is when there's a couple of these bits on the hardware, in particular like the start of frame bit. And I would like to know when if that transitions at a slightly different point in time to when the start of frame interrupt happens. Would be interested to see if there's some differences like that. Because the test that we wrote here will not measure that. So I somewhat suspect that may be related. And I kind of want to explore those kind of avenues while we're here, because we sort of have the code to do it. We're sort of in the headspace to do it. But one of the things I want to do as well is I actually want to try running a couple of these things in Reality Boy, the older emulator. I may start digging into that code a bit, just to see how our VIP timings differ from theirs. Because they seemed a lot more accurate than Minefin, at least, which is kind of what I was somewhat looking at before. So yeah, there's places to dig. But like if like Space Squash runs fine in that, and then Mario Tennis runs fine in that, might want to dig in there just to see if there's anything we missed. Because like, for example, if this was related to different timings in the VIP that we haven't covered with tests, we should be able to see that in their code. And with how accurate, at least in what this test tests, with how accurate that emulator was compared to the hardware, there might actually be some insightful stuff there. think. Yeah, the Warrior World game on the system is really good. Legit, pretty fun. Yeah, the audio effects are particularly impressive in that game. It's just super solid, except those weird glitches at the start. Ugh. I'm straight up disappointed, you guys. I totally knew that this could happen, but a little bit annoyed. But I'm going to use the restroom, and I'll be back. And I'm back. So the first thing that I'm thinking about is, in order to signify the start of a frame, we wait for game start and frame start to happen. And I wonder what would happen if we just waited for game start. And I think the reason why I did that is because we end the capture when we don't have frame start. You know what might be a better way to do this? Because we need to do both of these in order to synchronize with the video hardware first off. But after that, we should be in sync. After like the first frame. And so I wonder if it would actually be enough to do this wait in the beginning, like before our main loop. And after that, we just pick one of these to sync on. And I would actually suggest frame start be the one that we sync on there. We're also not doing any captures of any of the state for the other frame while the drawing is happening. And my big concern is that these may not happen at the same time. That's my big worry here. Because in the Mario Tennis bug, it seemed that the conditional that it would branch on that would cause it to cause problems was this frame start bit. But maybe it was waiting for a game start interrupt, for example, without that bit being set. Maybe that's the difference. I'm not entirely sure. Because we have a couple possibilities here. It's basically the game start could happen before the frame start. The game start and frame start could happen at the same time. And the frame start and the game start could happen at different times. Or like, yeah, the other one first. I'm trying, I could probably log that, but I'm just wondering what's the best way? Because we need to synchronize with the hardware in order to start when game frame is correct. But then it's basically every other frame start that we wait for. I'm actually just going to try that. So we end up with this, which is actually just this. Yeah, we don't have printf that we could use. Whoops, that's the wrong folder even. It's interesting is how different this got. Or what if we did this? Wait for start of game frame, and after that we just sync on frame starts. Still a bit interesting how close we are to Midnaffen in this case, and how far we are from Reality Boy. I'm really curious to see what this looks like on the hardware. Just trying this. Because all of our captures basically assume that those happen at the same time. I guess if game frame fired before frame start, then every time at the beginning of the frame, like at the beginning of our capture, we would see game frame would be set. Like it would already be set the first value that we capture. Or actually it wouldn't be, because we reset pending interrupts here. We should actually not do this when I think about that. I want to see how this looks since I've already waited this long. Exactly, Alkama. But yeah, this right here would actually keep us from seeing that stuff. And I don't really see the value in clearing this here either, because we clear it here and then we wait. Also, we don't need this clear, because that's superseded by this one. So this is what I'm thinking we should actually do. But yeah, I'm going to run that on the hardware really quick. Okay, first of all, Rustro Boy actually looks great in this test. Basically looks identical to this. I think this one's a little bit further, maybe not, but it basically looks perfect with that test, that's really good news. I don't think we could have said that before we started this, so that's nice. But I'm really wondering here. Okay, that's a bit concerning. So is this not at all what I would have expected as output here? Rush to Boy, interestingly enough. Oh, that's the padded one. There, it looks pretty much the same. That's a bit odd. So we wait for game start to make sure we're synced with the hardware so that whenever we start doing this, we're at least within the right frame. And then we wait for frame start. Oh no, I think it early's out here because suddenly frame start is set. So we at least need to do this. Actually, let's do it this way. Let's try it that way. So only clear that one bit because that's the condition on which we end the loop. So here we at least see some more sort of lingering bits, which I would have expected. Those would have been bits from like the last frame or the last thing it ran through. I don't know if all the bits would be triggered, but a lot of them should be. Like this is more or less what I would have expected at least. And what I kind of like about this is that we're only syncing to frame start here now, which is nice. Hey, it's crying. See which bits these were again. Kind of interesting that I'm guessing this is the end of the display ones, which we are going to see having been set from the previous frame because the display is going to happen again when we're not capturing. Drawing finished, also not surprised to see that because that also happens in the frame that we're not watching. So we're missing Y position match here. Doubt that's a problem. Start of frame processing. Happens out here, and that's probably when we stop capturing. Start of drawing as well, and then yeah, left and right finished. Display not ready. I'll run this on the hardware. Also, Where's game start here? Wait a minute. I don't know what terminology this one uses. It's not this, is it? I don't think it was. Oops. Oh yeah, okay, so what this says is start of drawing is actually the game frame. That's strange, actually. Yeah, I'm going to run this on hardware, but I may have totally messed something up conceptually because of the documentation being inconsistent. Okay, so this totally matches. Rush to Boy is totally matching what the hardware is doing. And if we run this with, for example, Reality Boy or something, we can see this is actually wrong, which is kind of nice. And Minafin gets, I think, closer to what ours looks like. But just in this test, ours is the only one that's definitively correct here. And these are going to be off by 1/8 of a display period, because that's what we fixed. But that's nice. Yeah, I did send output pad, but output pad, it gets built at the same time as output. It has to be padded because of the way the flash cart works. And then pushing this button that pulls up the flash utility, it actually runs a script right before that generates output pad just by padding the output ROM. So that's why those are different. But I may have mixed up this game start and then when it starts drawing. No, I totally didn't, because we want to capture the one when it draws in order to get the, there's a end of drawing interrupt that we wanted to get. Drawing finished here. So that's actually correct. So yeah, the start of drawing thing at the end here. It's stable here. It actually flickers on the hardware, which means it's slightly different. Hey, Legacy Casey. Thanks for the follow. I don't think that's going to be significant, because for what we're looking for, that would have had to be like consistently gone. But on the hardware, it matches this oftentimes, and sometimes it doesn't. And I guess what that tells us is that the start of frame processing and then the game frame thing actually do happen at slightly different times. But I don't think that's significant here. I think also we're watching the wrong frame currently now that we've synced it like this. I think we're now watching the frame where it doesn't draw, because right off the bat, drawing finished is set. And then at the end of the frame, we're seeing the start of drawing. So I think that's happening in the other frame. So I think we're actually out of sync now, which is interesting. So I wonder if that's possibly because we wait for game start here and not frame start. Which again is the start of when it starts drawing. I guess though, so one of the things, what am I trying to say here? So if we get game start, then sometime later we're going to get the end of drawing. And I'm guessing those will basically never happen at the same time. But we can probably assume that at some point between those, if that takes a non-zero amount of time, that frame start would have happened. So I wonder if, to synchronize with the hardware here, what we want to do is we want to wait for game start. Then we want to wait for drawing finished. Then we want to clear all the interrupt bits. Wait until frame start happens again. So we could imagine the start, and then we'll be in a drawing frame. Wait for drawing to finish for that drawing frame. And then we wait for frame start to happen again. And then that'll put us in the just display frame, the not drawing frame. And then we clear the bit, and then we start waiting for frame start again. I think that's what we actually want to do here. It'll sound a little more convoluted here, but I think this actually makes sense. This is our drawing process is over. Something like this. So in this case, we're waiting for a drawing frame. We're going to wait till drawing finishes in that frame. We're going to wait until the end of that frame. And then here the registers will be cleared again, and then it's going to wait for the start of the frame after that, which I think should be a drawing frame. And then we should be synchronized with the hardware. Thinking that's what changed there. Gotta clear that builder again. So here's what Minafin looks like, and now we have drawing finished interrupt over here again, which is what we wanted to see. So that's good. Rally Boy also looks similar. Rusho Boy as well looks similar. Yeah, so we get drawing finished sometimes. Yeah, so we're definitely synced because we get start of drawing is going to be set by the time this starts, it looks like. So we wait for, in this case, we wait for start of frame processing. And then start of drawing will have been set here, it looks like, consistently. Display finished, actually these are the display finished ones. So this is start of drawing and this is start of frame processing. Right, because we wait for this and then we clear it in the initial value. So that's why that's not set there. Yeah, drawing Y position matched here, drawing finished, and drawing exceeds frame period. I'm going to run this on the hardware. All I've done here is sort of change the synchronization criteria. And I really want to observe the relationship between game start and frame start. There we go. And the nice thing here is that if this doesn't work, or actually with this synchronization, we should actually just be able to change this to game start, and then we're going to watch from there instead. Which might be interesting. You know, another thing we could do, and I don't know why I didn't think of this. We could actually just capture. We could have it set up to draw and display every frame and then just capture every frame so that they're no different. And then we could always sync on game start. I think that's probably a better idea. I don't know why I didn't do that before. I guess because I assumed the rendering would take a frame and then we would do that in sort of the dummy frame. But in this case, we would just drop frames if that wasn't fast enough, and that would be fine. That would still should give us what we need. Yeah, I think that would actually be better. Hey, Anarchy. I think I'm going to try that. Yes, other than that thing that we saw earlier where the drawing at Y position match thing actually fires like twice out here, this looks exactly like on the hardware, which is what we want to see. Hey, DiffBram. So that's a good sign, but I want to try this. Like, if we just synchronize on game start, we should be able to see all the transitions. So here's what we're going to do. We're going to set, like, the changes we made here weren't that valuable because we didn't see any differences. So we're going to set frame cycle to 0, and then it's going to display and draw every frame. So then we should only need to sync to frame start. So we're going to wait till the start of nothing out here because we'll just sync on game start. Clear that one bit. And we're just going to capture until we see it again. And then we're probably going to end up skipping some frames in here, so we won't be running at full frame rate, but that should be fine. This should look more or less the same. Maybe a little different, like this kind of stuff. This was kind of interesting. Try this on the hardware. I mean, at least if nothing else, we did fix that virtual bowling bug, and I really like the consistency that we're seeing against the video hardware here, at least. That's pretty nice. But I'm really hoping to see something that differs here so that we can make it match. And the reason I'm looking at these two bits is just because we used them both as a sync point before, but they may not actually be in sync. No, there's no audio interrupts as far as I know. So what I am seeing is that start of frame processing. So hold on a sec. One thing I'm seeing here is this start of frame processing thing here. Is always set by the time we end the loop, but the game frame one, or was it the other way around? Hold on. Yeah, so the start of frame one is solid, but this one flickers. The game frame one. And so I wonder, let me sync on frame start as well, because these should be roughly the same now. We don't need to do this here either, do we? Because we're going to clear it here. Because I still am thinking that these are out of sync, and it may be the case that one of these always fires first. And in that case, we would get a per frame interrupt. For example, the game start without frame start being set, or maybe it's the other way around. And that might explain a bit of what's going on with Mario Tennis, hopefully. So it looks the same, suggesting that they should happen at about the same time. I'm hoping one or the other of these starts flickering when we actually view it on the hardware. So I'm going to try that again. So interestingly enough, it's still this bottom one that flickers, regardless of which one we sync to. Bottom one is the one that's changing here. while I've got this here, I want to look at a different register. I think that's all we changed now. Still looks like how I would have expected. Just really quick here, I'm gonna look at this as well. We don't do this either. So Minafin just goes to white. So it's Reality Boy, and Rush Boy probably will too then. Which means it's hitting way too many of these that are changing. Yeah, at this point probably could change that, Drew, but I need as little of those things to change in my head as possible right now. It's interesting though that the bottom one here is always the one that flickers. And that to me says that the frame start is happening slightly before this sometimes, or from what we can see doing this test at the same time. And it makes me think that this might happen right before this. Let me find some of these notes that I had as well. It might be so close that like hold on. Several of these things. So we get the interrupt, push all the registers, then this happens. Right, this back there. So if these did happen at a slightly different time, wouldn't have much leeway before it would actually check that and clear this. The other thing here is I don't think it ever touches the actual register again. I think it caches the value of the register here and puts it in here. No, that's storing R20 into the clear regs left to right here. Load it into R10. This goes into R20. R1. Do we have this anywhere else? 16R1. No, because like here it loads it again. The actual value. Checking different bits of that. Okay, so never mind. So this does actually read it again from there every time. Yeah, like here it does it again. So it seems so this just straight up reads the value and then writes it back. And then it seems to check individual bits later. Hold up. Oh, I have a whitelist chief detector. I add people on it if they've been around a while. Wait a minute. Am I reading this wrong? I totally am, aren't I? Because this is the actual address here, isn't it? Yeah, I think I read this wrong. Yeah, because somehow at this value, this ends up being where this address is stored, which is a bit weird. And then it will usually read via indirections there to actually get the value. So for example, here it's clearing a particular bit. In fact, it's clearing 8.4. It's clearing the drawing finished bit here, for example. And then here, moves that into R11. Here it does some weird stuff. Clears some different bit that I'm not sure what that is. That one seems odd. Actually 78 based on R11. Ugh, read it wrong again because it's only 0 off of here that we need to look at, which is probably why I didn't look at these other ones before. For example, this gets read to R10, but that's 4 after that, so it's a different register. R11, it's again totally different register. 78 off of that, and then this is R12. It's just added to R11. Some offset here. Don't think this is particularly relevant, actually. Because that same address where the inner pending, that's also the first address for all the VIP registers. So it would make sense that it would use that as a base a lot. But this is just loading the address. Here that goes into R10. 4 off of that. Yes, for example, here we get R10, and then this is the interrupt clear reg, which also was up here actually. Should clear 8. Which is start of drawing actually. Yeah, and this one clears the start of frame processing. But how often does it actually read this? Seems to write to that. It's looking like it reads from this value a lot less than I realized. It has a big old brick. Just to add a little bit here. This is totally what's happening here. I think it needs different instructions here due to the size of this operand. And here, 4 off R10. Wait a minute. I don't want to just try staggering them because I have no idea how large that gap should be. So I kind of want to get a better overview of where this is being touched first. There's only a few places where it clears the registers, or where it just writes back the initial value to that. So it like effectively clears a bunch of those bits. And here it cleared the drawing finished, cleared the start of drawing, and it cleared the start of display frame bit. Maybe we'll just try that. So I think the easiest way to do this, we have the frame clock here, and assuming the game clock would maybe happen a little later, let's do this. Just move this outright to here. Oops. Not that ROM. Actually, I do want to watch it run that. I want to see how different that looks. So that's a big difference. And I think that's what this is showing. No, it should be these two. So it's probably this that we're seeing from staggering that like that. That didn't work. Let's try the other way. Just because I'm curious. Okay, so it still broke, but it broke differently, which is actually somewhat interesting. I'd be really surprised if this were the correct order of these two. And of course, this is going to be wrong, just because of how far apart they are. And even then, like it feels pretty sketchy that this would fix it, but these are the bits it's looking at, it would seem. Very interesting. So that was just moving that logic, yeah. Well, I'm getting a bit stumped, but I think it's time to cut off the stream. Have a bit of a think about this and hit it again next week. In any case, we did make a little bit of progress by fixing graphical glitches in virtual bowling. Just going to undo this change here, so don't forget. But yeah, we'll hit this next week. See if we can make some more progress. Anyway, thanks guys for hanging out. And I'll see you next time.